A 5 million square kilometer hole has opened in Earth's magnetic field. That's an area nearly half the size of continental Europe, expanding faster than expected. Right now, as you're watching this, satellites above us are being bombarded with radiation they shouldn't be exposed to. Astronauts are at higher risk of cancer, and the systems we depend on every single day, GPS, communications, weather forecasting, are becoming less reliable because of what's happening in the South Atlantic. But here's what's really concerning. This acceleration started in 2020, and it's still accelerating. The weakening in certain areas is happening faster than our worst models predicted. And while governments and space agencies track it quietly, we're not being told how serious this could become. The South Atlantic Anomaly isn't new. It's been weakening for centuries, but what's happening right now is different. Between 2014 and 2025, just over a decade, the anomaly expanded by an area nearly half the size of continental Europe. Think about that. We're not talking about a gradual change measured across geological timeframes. We're talking about dramatic expansion in human observable timeframes. But here's what they're not emphasizing. The expansion rate accelerated in 2020. A region southwest of Africa where the magnetic field is weakening has been experiencing even faster weakening of Earth's magnetic field since 2020, according to ESA's official statement. The anomaly was supposed to be a single, stable weakness. That's not what's happening. ESA scientists discovered it's splitting into two separate cells. The NASA models show the split continuing through 2025 and beyond. One cell is centered near South America, the new one is moving westward toward Africa, intensifying as it expands. This isn't random. It's not natural variation that we should ignore. Here's what NASA and ESA know but downplay. This weak spot is letting radiation through that should never reach this close to Earth. Normally, Earth's magnetic field deflects charged particles from the sun. It's our shield. But over the South Atlantic Anomaly, that shield has failed. Satellites passing through experience higher radiation exposure. More radiation exposure means more equipment failures. Let's look at the consequences. Hubble Space Telescope. NASA has to power down Hubble's instruments when it passes through the anomaly zone. They don't advertise this, but it happens every 90 minutes when Hubble orbits over the South Atlantic. Systematic downtime, reduced observations, delayed science. GPS and navigation systems. Military and commercial satellites that provide GPS accuracy are being exposed to elevated particle radiation. The more radiation, the more data corruption. The more data corruption, the less reliable your navigation becomes. International Space Station. Astronauts aboard the ISS pass through the anomaly zone regularly. Exposure to radiation increases their lifetime cancer risk. ESA and NASA know this. It's factored into mission planning, but it's not factored into public warnings. Communications networks. The satellite network that keeps us connected, cell service, internet, phone calls, relies on satellites that pass through this zone. More radiation exposure means more potential for blackouts. The official story? It's being managed. Operators shut systems down before the anomaly, restart after. Problem solved. The real story? The zone is growing. The radiation exposure is increasing, and the systems designed to handle this are being tested in ways they weren't designed for. What troubles us is the language. Scientists say the anomaly is expanding as expected, but they also admit that since 2020, it's expanding faster than their early models predicted. So which is it? Expected or unexpected? The acceleration tells us something is changing in Earth's core, and they're not being transparent about what that means. Deep below us, 3,000 kilometers down in Earth's outer core, a swirling ocean of molten iron generates our entire magnetic field. Normally, magnetic field lines flow out of the core in the southern hemisphere, but beneath the South Atlantic Anomaly, something unprecedented is happening. The magnetic field is going back into the core. These are called reverse flux patches, and here's the part that's being buried. We don't fully understand why they're forming. Chris Finlay, professor of geomagnetism at the Technical University of Denmark, is being careful with his words. He acknowledges the anomaly is changing differently toward Africa than it is near South America, suggesting unique geological processes are at play. But he stops short of explaining what those processes are. The official explanation? Turbulent flows of molten iron in the core are creating these reverse flux patches. It happens. The core is chaotic. This is normal. But the acceleration since 2020 isn't normal. Something changed, something accelerated, and scientists are monitoring it carefully, but they're not publishing timelines about what comes next. Here's what we should find troubling. Other anomalies exist. The magnetic field is getting stronger over Siberia, but weaker over Canada, where it is shrunk by the area of the size of India. The magnetic poles are shifting. The entire pattern is redistributing. Is this leading somewhere? Scientists won't commit. The official position is we don't see evidence of an impending magnetic reversal, but they also say we're seeing a decade to century timescale fluctuation. What does a century timescale mean for us? ESA swarm satellites will continue monitoring through 2030. That's their mission extension, just 5 more years of data collection. But what happens after? What happens if the acceleration continues? What happens if the reverse flex patches keep multiplying? The honest answer we get from scientists: we don't know. Meanwhile, our society has become more dependent on satellite infrastructure than ever before. GPS, military communications, weather forecasting, air traffic control, it all relies on systems passing through the radiation zone. The bigger the anomaly grows, the more systems are exposed. The longer they're exposed, the higher the failure risk. Space agencies are quietly preparing. They've already designed new spacecraft with enhanced radiation shielding. They're developing new protocols for managing satellite systems through the zone. But these preparations are happening in technical documents, not in congressional hearings or public announcements. We should ask why. If this is being managed, why isn't it being communicated? If the expansion is accelerating, why are we hearing terms like normal variation? If the scale of change is unprecedented, why are we being assured that everything is fine? The data tells a different story than the reassurance. Let's be clear about what we know. Earth's magnetic shield, the only thing protecting us from solar radiation, has developed a massive, expanding weakness. It's grown by an area nearly half the size of continental Europe in just over a decade. The rate of expansion accelerated in 2020 and is continuing. Scientists don't fully understand why, and every system we depend on is becoming increasingly vulnerable to radiation exposure. The question isn't whether this matters. The data proves it does. The question is, why are we finding this information on research papers and ESA announcements instead of emergency briefings? The answer might be the scariest part.